Alright, welcome. In this video, we're going to be doing some quadratic formula practice, and we're going to be working through Algebra 2 Homework 4.5. So the first one is 2x squared minus 12x equals negative 18. So always the first step for these is going to be set the thing equal to 0. So I'm going to add 18 to both sides, and I'd have 2x squared minus 12x plus 18 equals 0. Now, we've got the quadratic formula. It works on any of the quadratic equations that are set to 0, but I think that this one might be factorable, okay? Or I can see that I've got three even numbers, so I can factor out at 2, and even if I don't decide to go with factoring, it'll make my computations much easier. Okay, so minus 6x plus 9 equals 0, and it's like, oh yes, this is factorable. I know two numbers that multiply to positive 9 and add to negative 6. That would be negative 3 and negative 3. Okay, and then I'll get either 2 equals 0 or x minus 3 equals 0 or x minus 3 equals 0, and that's telling me that x is only equal to 3. Right, now if you'd wanted to use the quadratic formula, this is what it would have looked like, but that would depend on you knowing what 8 times 18 is. That 8 times 18 is 144, and that's not arithmetic I've really got just in my back pocket, so I wouldn't necessarily expect you to have it either. Now, the quadratic formula does come down much, much easier if you divide both sides by 2, or if you are just doing it on x squared minus 6x plus 9 equals 0. It works out much better, but that's what you would do if you're using the quadratic formula. Alright, here we've got another one. This one looks pretty bad. But actually, this one's going to work out just fine. This one's another perfect square trinomial. I feel like I copied these problems from the wrong place, but it's alright. Maybe I'll use the quadratic formula on this one. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I'm not even going to do the complete the square method for this one because this is one where you just want to use the formula. So this is going to be negative b is negative 40 plus or minus the square root. B squared is going to be 40 times 40 is 1600 minus 4 times 25 times 16. I actually can do that one because I know that 4 times 25 is 100 and 100 times 16 is 1600, so it's going to be the square root of 0 all over 2a. Okay. So this is going to be negative 40 plus or minus 0 divided by 50, so that's just negative 4/5. Another one, and we're going to start by setting this one equal to 0, so 5x squared plus 7x, add 6 to both sides, would equal 0. Alright, and then from here I'm going to always check to see if these things are factorable. Do I know any factors of 30 that add up to 7? For 30 I've got 10 and 3 and 5 and 6. And neither of those are going to add up to 7, right? If I had negative 30, maybe I could make that, add up to positive 7 with one of them being negative, but that's not what I've got. So I'm not going to be able to work with that. I think I'm going to have to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, and if you're having trouble memorizing something, one of the best things you can do is write it down and say it out loud each time you write it down. Well, it looks like you are working on a problem set where you've got about 20 chances to do that, right? So that would probably be enough for you to remember the formula, at least in my judgment. So negative b is going to be negative 7 plus or minus the square root of b squared minus 4 times 5 times 6. Make sure I copy the problem right. Nope, I definitely copied the problem, right? Okay, all divided by 2a is 10. Alright, now I'm seeing that it's got me taking the square root of like 20 times 6, or 49 minus 120, and that's going to be a negative number. So I'm going to say, that's the square root of a negative number, so there's no real solution. Right, now this one, okay, it's already set to 0, so we're going to be able to go. I'm going to check to see if it's factorable. Are there any factors of positive 4 that add to negative 1? Not that I'm aware of. So I'm going to go in here, and I'm going to use the quadratic formula, right? X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. That's going to be negative 1, so it'll be positive 1. Plus or minus the square root of b squared is negative 1 squared, positive 1, minus 4 times 2 times 2. Okay, that's got me taking the square root of a negative number, so I know that's going to be no real solution. Here's one that I am looking at, and I'm thinking this one's factorable. Okay, I'm looking and multiplying 8 times 1, and I'm saying, what are two numbers that multiply to 8 while adding to negative 6? And that would be negative 4 and negative 2. So I can go in here and I can split up negative 6x into negative 4x and negative 2x. And then I'll factor by grouping. Okay, I'll say what's common to the first two terms. I've definitely got an x in both of those and a copy of 4. So I'll factor out a 4 and an x, and I'll be left with, what do I multiply 4x by to get 8x squared? That would be 2x. And a minus 1. Okay, what do you multiply 4x by to get negative 4x? That would be negative 1. Then in the second two, I don't really see anything common to both of them, but I know I need to get 2x minus 1 out of that to eventually factor 2x minus 1 out of the next expression. So I think I just need to factor out the negative, and then that'll work. So I'll factor out maybe a negative 1. And so what do I multiply negative 1 by to get negative 2x? Well, that would be positive 2x. And then negative 1 times negative 1 is positive 1. Well, that's so... Okay, we're going to factor it like that, and then we can factor 2x minus 1 out of both sides, or out of both terms. And I'll be left with a 4x and a negative 1. Okay, and so I can solve this one. And this is way easier than going and doing quadratic formula. Or maybe you disagree. Maybe you think the quadratic formula is much easier, and then you should do that. Okay, I'll show you what this would look like if you did quadratic formula here in a second. But let's say 2x minus 1 equals 0. That's where 2x equals 1 and x is 1/2. Okay, over here, this could be equal to 0 if the second thing in parentheses was 0, so 4x minus 1 equals 0, 4x equals 1, x is 1/4. Okay. Now if you had used the quadratic formula, negative, so that's positive 6, plus or minus the square root of b squared is 36, minus 4 times a times c is minus 32, divided by 2a would be 16. It looks like I'm going to need a little more room here. Okay, that's going to be the square root of 4, so that's 2 over 16. And, you know, like, I mean, I guess this is far enough in, like, for your response or on a quiz, but think about multiple choice. You're going to have to go farther. Your answers are not going to look like 6 plus or minus 2 over 16. We need to be able to take that all the rest of the way. So that would be 6 plus 2 is 8 over 16. That's a half. Or, if I did 6 minus 2 divided by 16, that would be 4 over 16, which is 1/4. Okay, so either way, you're going to get the same answers, provided that you do it right. And on number 6, we've got 1, and this looks like it needs to be set to 0. Okay, so we can do that. We'll subtract 8x and add 3 to both sides. So I'll have 2x squared minus 8x plus 3 equals 0. It's like, do I know any factors of 6 that add to 8? I know factors of 8 that add to 6, or negative 8 that add to 6. I don't see this happening. 3 and 2, 6 and 1, I don't know what else there would be. No, nothing. Okay, so we're going to use quadratic formula. Okay, so we know that x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so that'll be negative of negative 8 is positive 8. Okay, b squared is 64 minus 4 times 2 times 3. So that's 8 times 3 is 24. All divided by 2a is going to be divided by 4. Okay. Now I'm going to say, all right, so this is 8 plus or minus the square root of, I think, 40, all divided by 4. Right. We haven't really talked about simplifying radicals in this class yet, so I'm not really going to do much with that besides to say that this is 8 plus root 40. I don't know if we really talked about simplifying fraction type expressions, so I'm not even going to get into that right now. 8 minus the square root of 40 all divided by 4. Okay, those are going to be our two solutions. Next, we've got x squared minus 4x, or x squared minus 4x plus 8 equals 0. This one's already set to 0, so I don't have to worry about that. I'm looking for things that multiply to 8 and add to negative 4, and that's not going to be able to happen. That's not going to work. So I'm going to use quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, that's no longer visible to you. So I'm going to. Oh, what I was saying was I think, I'll solve this one through and I'll show it to you if you were using complete the square on this one. If you just like couldn't find it in yourself to memorize the quadratic formula, which I'm telling you, it's going to serve you well. There's plenty of these, like, I'm trying to look for another one where I use the quadratic formula. Number three is a good example of one where you would not want to use complete the square because you'd have to have 7 divided by 5, and then you'd have to divide that in half and square it, and then all of a sudden your numbers are really bad also. Okay, but enough of that. Let's just plug in the numbers here. So negative b is positive 4 plus or minus the square root of b squared is 16 minus 4 times 1 times 8. So I'm taking 16 minus 32. That is divided by 2. That's the square root of a negative number. We say no real solution. Let's talk about what would happen if we tried to solve this one with completing the square. What if we did complete square on this one? So x squared minus 4x plus something, just gonna leave space for that, plus 8 equals 0, and then I'm going to add that same number to both sides. Okay, so I take the negative 4, I divide it in half, that's negative 2, and I square it, that's positive 4. Okay, so I'm going to add that there. I need to add 4 to both sides. And then I factor the thing in the box up, that's going to be x minus 2 squared. Also subtract 8 from both sides, so I get equals negative 4. And then when I go to take the square root of both sides, I'm going to see that I'm taking the square root of a negative number, and I'm going to see, okay, so x minus 2, or maybe the absolute value of x minus 2 equals the square root of negative 4, which is not a real number, so I say there's no real solution. Right, here's one where I'm thinking factors of 44 that add up to negative 12, 11 and 4, 22 and 2, 44 and 1, none of those are adding up to negative 12, or in any kind of combination, so I'm not going to be able to factor this one. I'm going to use the quadratic formula, and then I will also solve this one with completing the squares. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2. Okay, so this is going to be negative b is positive 12 plus or minus the square root of b squared is 144 minus 4 times 1 times 44. Okay, so I don't think about this. 4 times 40 is 160. Oh, so this is the square root of a negative number. I did not. Okay, yeah, I didn't see that coming. I kind of wish it was 11. Oh, but then that would have been too easy, right? You wouldn't have needed the quadratic formula. Oh well. All right, and then what's going on here? Okay, I'll divide it by 2a, so that's 2. But again, 4 times 44 is bigger than 160, so 144 minus a number that's bigger than 160, it's definitely going to be negative. And so I'm taking the square root of a negative number, and I say there's no real solution. Okay, if I'd wanted to do this one with complete the square, I can do that. I just add some room to add the same thing to both sides. So x squared minus 12x, I'm going to add something there to make it a perfect square trinomial. Then plus 44 equals 0. Okay, so I think, what am I going to add to both sides? Half of negative 12 is negative 6. We square negative 6 and we get positive 36. So I'm adding 36 to both sides. I'm going to factor up the thing in the box, the x minus 6 squared, subtract 44, and then, okay, when I go to take the square root of both sides, I'll get the square root of negative 8. And that's not a real number, so I would say no real solution. Number 9 is also one that we're going to need to start with by setting it equal to 0, and so I'm going to add 3x to both sides. And I'll say 0 equals 2x squared plus 3x minus 4. So are there any factors of 8 that add to positive 3? Or factors of negative 8 that add to positive 3? And I'm not thinking of any. So unfortunately, I'm going to have to use quadratic formula. That's okay. And, this one is not going to work out well by completing the square, but I will show you how it's done. Okay, so in case you were just die hard, I'm going to solve all these by completing the square. I'll show you how it would be done. So we got negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Okay, so negative b is negative 3 plus or minus the square root of b squared is 9 minus 4 times 2 times negative 4. Okay, so that's going to be 8 times 4 is 32 plus 9 is 41 inside the square root. So I'll hold on to that piece of knowledge for a second. All divided by 2a is going to be 4. Okay, so I've got negative 3 plus the square root of 41, all divided by 4, or maybe negative 3 minus the square root of 41, all divided by 4. Now, if you were thinking you wanted to solve this one with completing the square, I mean, you definitely can. Okay, so I'm just going to add room to, add the same number to both sides, but I'm going to have to be careful here because I got to get rid of that 2 first. X squared plus 3 halves of x. And then I'm going to leave room to add to make that a perfect square trinomial. And I'm subtracting 4, and I'm going to need to add the same number to both sides. When determining what number to add to both sides, I'm going to take that positive 3 halves and go over here. That's not good. Oh, it's like really low too. That's going to be troublesome. So, but I think I can get through this. 3 halves, positive 3 halves, wait, divided by 2. Oh, and I lost my highlighter. 3 halves divided by 2 squared. That's what I'm going for. Okay, I gotta go get a charging cable. And when I divide 3 halves by 2, that's going to be 3/4. And that's going to be, if I square 3/4, I'm going to get 9 over 16. So I'm adding 9 over 16 here. But then what I'm really adding is 2 times 9 over 16. And, okay, if I doubled 9/16, I'd have 18 over 16, which is going to be the same as 9 over 8. So since I added something equivalent to 9/8 on the right side, I'm going to need to add something equivalent to 9/8 on the left side. And then, okay, I'm going to factor the thing in the box just like usual. Take this a little bit slower. So it's going to be x plus this number squared. Okay, so x plus 3/4 squared minus 4. And then I'm going to add 4 to both sides. Now in terms of eighths, 4 is 32 over 8. So I'm going to add over here, and I get 32 over 8 plus 9 over 8 is 41 over 8. Okay, that's where that 41 is coming from in the square root, is equal to 2 times this thing squared. Okay, divide both sides by 2. And so you end up with, 41 over 16. Okay, because divided by 2 is like multiplying by half. You see, this is just not as nice, especially in this case, as using the quadratic formula. So that's why I recommend just like spending a little bit of time committing to yourself that you're going to remember the quadratic formula, because really, in the big picture, it's not that hard to remember. Okay, so I'm going to take the square root of both sides, and if I take the square root of 41, I don't know what that is, so I'll just leave it like that. The square root of 16, that's 4. And that's going to be equal to the absolute value of x plus 3/4. Okay. That would mean if I drop the absolute values, I need a plus minus. And then that's where I'll get x equals negative 3/4 plus or minus the square root of 41 over 4. Okay, and that's kind of a lot. Okay, compared to just here are the numbers, let's plug them in, let's get our solution. Okay, but, the choice is yours. Right, the next set of questions says find the zeros of each function. Well, the 0 is a place where f of x equals 0. It's also an x-intercept. That's where y equals 0. It's also sometimes called a solution or a root. I got all sorts of words for these. So, okay, we're going to go over here. And we're going to... it's not factorable. Unfortunate. Not factorable, but what I can do is use the quadratic formula, I guess. So it's a 0, so I set this thing equal to 0. So x squared minus 2x plus 3. Okay, we've got a quadratic equation set to 0. We can use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so when I plug that in, I get 2 plus 1 minus the square root of negative 2 squared is positive 4 minus 4 times 1 times 3, and that's definitely going to be the square root of a negative number, so I know that there's going to be no real solution. And I guess that I would say that since there was no real solution to that equation, there are no zeros. Okay, another one they want us to find the zeros of is x squared plus 4x plus 8. Again, this one's going to have no zeros. B squared minus 4ac. All three of these are going to have no zeros. What a waste of your time. Okay, I'm not really sure. I obviously should have looked a little closer at this homework before I just copy-pasted it from a previous year. For it's the homework that somebody else wrote. That's what I get. It'll be all right, though. So I'm just going to tell you 11 and 12 both are going to have no solution. I'm going to go really quickly through these because you just saw one where it came back no solution. You definitely didn't need to see like a bunch that are going to have come back no solution. Okay, I'm just going to say b squared minus 4ac on this one. If you can see that it's coming back no solution, you don't need to do the whole formula. You can just say that, hey, this b squared minus 4ac equals 16 minus 4 times 1 times 8. That's less than 0, so no solution. And as a result, there are no zeros on the graph. Okay, I think I showed you this in class in the lesson, but what this would look like, positive leading coefficient, is it looks like this, where it's just not ever running into the x-axis. All right, number 12 is more of the same. It's going to come back with the exact same result. It's going to be x squared minus 10x plus 37. Right, so I go over here and say, okay, I can see b squared is 100. 4ac is going to be bigger than 120. So, okay, because it asks for the zeros, I'll set the thing equal to 0. Show some knowledge here that I know that find the zeros means set f of x equals 0 and solve for x. Okay, but then I see, all right, this is going to come back with no solution. So this is b squared minus 4ac equals 100 minus 4 times 1 times 37 is pretty clearly a negative number. And so I'll say it has no real solution. And as a result, there are no zeros. Okay, just for your forgiveness on that. That was kind of a waste of your time. Oh, looks like there is no number 13, so just move on to number 14. Find the type and number of real solutions for each equation. Okay, the type of solutions, I meant to get rid of the type and number, or just the type and in there. I just want you to find the number of real solutions for each equation. That's where we're going to use the discriminant. We're looking at b squared minus 4ac. So kind of the guy, a little bit more room here. Maybe I'll just move this down a little bit and put down the rule that we're going to be working off of. So b squared minus 4 times a times c. Okay, if it's positive, then I have two real solutions. If it's negative, I have no real solutions. And if it's 0, then I have one repeated solution. Positive, negative, 0, yeah, one real solution. Okay. So I'm going to go over here and I'm going to do, all right, number 14. Is going to be, where I lost it? Oh, 2x squared plus 5 equals 2x. So I'm going to set it equal to 0 so I can use the discriminant. Okay, because the quadratic formula, it only works when it's set to 0. So I'm going over here, and I'm going to say, all right, 2x squared minus 2x plus 5 equals 0. b squared minus 4ac equals negative 2 squared minus 4 times 2 times 5. That's definitely less than 0. I'm going to say 0, no real solutions. I'll just say no real solutions. That's what I've been saying the whole time. Okay, number 15. Try to squeeze these all in. 15. Oh no, there's 6 of them. Okay, well, that's fine. 4x squared minus 28x. Okay, they say equals negative 49. I'm going to just set this thing equal to 0 right away. Oh boy, this looks like it might need a calculator, but I'm going to try to, if at all possible, hit this, like, figure it out without using a calculator. So b squared minus 4ac is equal to 28 squared minus 4 times 4 times 49. Alright, so the question is, what's bigger, 28 squared or 16 times 49? Oh, they could be the same. Okay, I'm trying to figure out, how would I figure this out? I don't know 28 times 28. Alright, I'm going to get into some arithmetic analysis here. That's 7 times 4, right? So I've got 7 times 4 times 7 times 4. Oh, yeah, so I can do this. This is 28 squared minus 4 times 4 times 7 times 7. Oh, look at that. Those are going to be the same number, right? 2 4s, 2 7s, no matter what order we multiply stuff in. So this is going to come back 0. Satisfied with that. And so there's one real solution. A little more real estate, so I can go over here and do number 16. So 3x squared minus 8x plus 8 equals 0. Okay, so we're going to do b squared minus 4ac. And that's going to be equal to 64 minus 4 times 3 times 8. Okay, 12 times 8 is 96. That's in the times table. So 64 minus 96 is less than 0. And this will have no real solutions. Number 17, 2x squared minus 3x equals 8. 3x. Now I might subtract 8 as well. Okay, now one thing that you may have noticed, or maybe they told you about in Algebra 1, that would be really nice if they did, was that if A and C have opposite signs, then you're always going to have two real solutions. So, and basically the reason for that, and this is something I did not even think to mention in class last time, but I'm going to show you why. Okay, if A and C have opposite signs, so suppose A is greater than 0 and C is less than 0, like exactly what we've got here. Okay, all that I need to, I'll put an x-axis in there. Okay, if C is less than 0, I'm going to say, with no loss of generality, that, oh no, I mean, this is going to be true. The y-intercept is below the x-axis, right? Because C is the y-intercept. Okay, what I'm going to assume with no loss of generality is that, I don't know, maybe when it hits this, it's going down. Okay, if it wasn't, it would just be kind of like mirrored across the y-axis, and we'd still have two solutions, right? Just can't avoid it because the parabola opens up. Okay. Now, if we switch this situation around and we said A was negative and C was positive, we'd have the same thing, right? A is negative, so, maybe it looks like that. Or, just so you can see what I'm saying, maybe it looks like that. Either way, there's going to be two x-intercepts, and so I can see there's going to be two solutions. I'm going to explain my reasoning in terms of b squared minus 4ac, but I just wanted to point that out for you in case anybody's watching and learning. So this is equal to 0. Make sure I copied it right. Yeah, okay. So 9 minus 4 times 2 times negative 8. That always ends up being, plus. They have opposite signs. So that's greater than 0. And then, yeah, I'm happy. Two real solutions. Okay, number 18 is 2x squared minus 16x equals negative 32. I feel like we've done this one already, but it's all right. They all start to seem familiar at a certain point. 2x squared minus 16x plus 32 equals 0. Right, I gotta set the thing equal to 0 so I can solve or use quadratic formula or do whatever I'm gonna do with quadratic. Okay, so I'm over here. Yeah, I mean, okay, but I don't know 16 squared, so it would be helpful for me to factor out the 2. so it's like x squared minus 8x plus 16. Oh, hey, this is going to be, that's a perfect square trinomial. Okay, I see it now. But to use it, the terminology we've been using, b squared minus 4ac. Okay, now if I do analysis on this thing that I just highlighted in yellow, it will be equivalent to, the number of solutions to 2x squared minus 16x plus 32 or whatever. They'll actually even be the same solutions, but it won't be the same graph if I'm just thinking about x squared minus 8x plus 16. It would be not as narrow, okay, because we know that that's what that multiplier of 2 does. It makes the parabola narrower. Okay, I think that's enough for that. B squared minus 4ac is going to be 64 minus 4 times 1 times 16, which is also 64, so that's going to equal 0, and I'm going to say one real solution. Number 19 is going to be... What? It's another case if I didn't catch this one when I was making the homework, but that's all right. I'm not scared. 3.2x squared. Been copying these in color. Wait, no, not 3x squared. I wish. 3.2x squared minus 8.5x equals negative 1.3. So I'm going to add 1.3 to both sides, set it equal to 0, and I'll analyze the discriminant. Oh, okay, I see how you're supposed to do this one. All right, so 8.5 squared. Okay, I'm proposing that this is going to be a positive number, okay? Because 8 squared minus 4 times 4 times 2. If I rounded the one down and the others up, it's still going to be positive, right? And that would be like the least it could be by my estimation. So I know that this is definitely greater than 0 because 8.5 squared is between 64 and 81. And 4 times 3.2 times 1.3 is going to be between 4 times 3 times 1 and 4 times 4 times 2. Either way, we're going to be having a positive number. And if you need more explanation on this arithmetic that I'm doing right here without actually computing the numbers, just come see me in the morning, or I'd be happy to discuss that. Those approximation techniques, that's probably not something you're going to have to do on a quiz or a test in this class, but those are kind of the number sense ideas that will come up in pre-calculus and calculus. I want y'all to have success in those classes too, so that's why we do these things. All right, it's greater than 0, 2 real solutions. Okay, so I went from not liking that problem to actually liking it quite a bit, and that was all right. Caused us to have to think about numbers, which I know is some people just really hate, but I mean, if you're expecting to be in a math class and not think about numbers, then it's probably not going to go that well for you anyway, so. All right, last problem, number 20. So we're going to find all values of c so that the quadratic equation x squared, oh yeah, I made this one up. This was a nice problem, I think. Minus 6x plus c equals 0. Okay, so find all values of c, so this is... Okay, yeah, and then in the next lesson, we'll let the unknown be the middle term, and that'll be fine too. All right, so x squared minus 6x plus c equals 0. So 20a, two real solutions. Well, two real solutions, that's b squared minus 4ac is greater than 0. Okay, so we're going to set up an inequality and solve it like we did in the first unit of this class. So b squared is 36. Minus 4 times a times c, which is what we don't know. That's greater than 0. So 36 minus 4c is positive. So 36 is greater than 4c. If I added 4c to both sides, I could divide both sides by 4, and I'd get 9 is greater than c. Okay, so that will be true when c is less than 9. Okay. For 20b, 20b is one real solution. So that would be where b squared minus 4ac is equal to 0. Okay, the solving would be no different, except instead of having a greater than, I'll have an equals. So I'm going to say, I've already done this algebra once. As well say c is equal to 9. Okay, and then, on my the most bang for my buck, in terms of area. Just put 20c right in here as well. No real solutions is b squared minus 4ac is negative. Once again, that's going to work out the exact same way. 36 minus 4 times 1 times c is less than 0. It's going to work out all the same. It's just going to be c is greater than 9. Okay, so that's definitely the type of question I might like to ask. Oh, but that's all. Okay. Yeah, I don't really have anything else for you. I hope this was helpful. Thank you for watching.